This is Rupesh Kumar from Government Polytechnic Narayankhed. Today I wish you share some information regarding the digital electronics. Subtopic is logic families. Subtopic is logic families. 1 minute. That on completion of this period, you would be able to know about the TTL, CMOS and ECL logic families and its specifications, compare the logic families, etc. First of all, I wish to share some introduction regarding the logic families here. Here, logic gates are available in the form of ICs. Logic gates are available in the form of ICs. ICs means integrated circuits. Integrated circuits means combination of transistors, gates, diodes constitute the integrated circuits. These ICs can accommodate various number of logic gates. We already know that ICs can accommodate number of logic gates and perform digital functions also. Thus, many digital functions have been realized in a variety forms. Each form is referred to as logic family. In this, we will know about the different logic families, and most important in this logic family is TTL logic family. TTL means transistor logic, which the circuits involved in the family with various outputs and their operations, that is CMOS and ECL also we can clearly observe in this logic families. Okay, now we are going to the topic now. Okay, now we are going for the classification of logic family here. First of all, logic families are we already know that logic families are available in the form of integrated circuit, that is ICs. As per the level of integration, these can accommodate various number of logic gates. As per the level of integration, these can accommodate various number of logic gates and digital functions. Thus, many digital functions have been realized in a variety of forms, and each form is referred to as a logic family. Once again I am repeating, logic families are available in the form of integrated circuit, that is ICs. As per the level of integration, this can accommodate various number of logic gate. As per the level of integration, this can accommodate various number of logic gates and digital functions in it. Thus, many digital functions have been realized in variety of forms, and each form is referred to as logic family. The digital logic family can be categorized as follows. Digital logic family can be categorized as follows. Okay, here I have shown the classification of digital logic family here. The digital logic family is divided into two types. First one is bipolar logic family. Second one is unipolar logic family. First one is bipolar logic family and second one is unipolar logic family. Again, bipolar logic family is converted into two types. They are saturated and non-saturated logic families. Next, unipolar logic family is divided into three types. They are PMOS, NMOS and CMOS. Okay, PMOS, NMOS and CMOS. Here saturated, non-saturated. Again, saturated is converted into 6 types. They are resistor transistor logic, that can be termed as RTL. Next, directed coupled transistor logic, that is DCTL. Third one, integrated injection logic, I square L. Integrated injection logic, that can be termed as I square L. Next, fourth one, diode transistor logic, that is DTL. Diode transistor logic, that is DTL. Next, high threshold transistor logic, that is HTL. High threshold transistor logic, that is HTL. Next, transistor logic, that is TTL. Again, the TTL is transferred into 5 types. Again, TTL is converted into 5 types. They are standard TTL, high power TTL, that is H, low power TTL, that is L, low power Schottky TTL, that is LS, Schottky SS. Okay, these are the different types of bipolar logic family. Saturated bipolar logic family values constitute the TTL logic family also. Now, non-saturated bipolar logic family is converted into 2 types. They are Schottky TTL and emitter coupled logic, that is ECL. Emitter coupled logic, that is ECL. These are the different logic families in the digital logic family. Once again, I am repeating, it is most important question. It can be given in 3 marks and 5 marks also. Okay, first of all, I wish to share digital logic family is divided into 2 types. First one, digital bipolar logic family and unipolar logic family. Bipolar means 2 types. 2 types means that one is saturated and non-saturated. Unipolar is 1 type, that is only one single type only it is there, that is PMOS, NMOS and CMOS. PMOS means P-type metal oxide semiconductor, PMOS. P-type metal oxide semiconductor. NMOS means N-type metal oxide semiconductor. CMOS means complex metal oxide semiconductor. Complex metal oxide semiconductor. Saturated is converted into 6 types. They are: first one, resistor transistor logic, that is RTL. Next, direct coupled transistor logic, that is DCTL. Integrated injection logic, that is I square L. Next, diode transistor logic, DTL. Next, high threshold transistor logic, HTL. Next, high transistor logic, TTL. Transistor logic, TTL. Again, TTL transistor logic is converted into 6 types. They are standard TTL, high power TTL, low power TTL, low power Schottky LS, next Schottky S. Next, non-saturated bipolar logic family is converted into 2 types. They are Schottky TTL and emitter coupled logic. Emitter coupled logic. It is bipolar logic family and unipolar logic family. In this, one more questions exist. How many types of unipolar logic family are there? What are they? There are 3. They are PMOS, NMOS, CMOS. He can ask also like that abbreviate PMOS, that is expand PMOS, expand NMOS, expand CMOS. Expand PMOS means P-type metal oxide semiconductor. NMOS means N-type metal oxide semiconductor. CMOS means complex metal oxide semiconductor. Again, he can ask like this also. How many types of saturated bipolar logic families are there? 6 types. Resistor transistor logic, RTL. Directed coupled transistor logic. Next, integrated injection logic, diode transistor logic, high threshold transistor logic, transistor logic. Next to that, how many types of TTL logics are there? Standard TTL, high power TTL, low power TTL, low power Schottky. Next, how many types of non-saturated bipolar logic families are there? They are Schottky TTL, emitter coupled TTL, emitter coupled logic TTL. Schottky TTL and emitter coupled logic ECL. Okay. Another type questions also there. They are expand RTL, resistor transistor logic, expand DCTL, diode direct coupled transistor logic. See, I am also confusing, but you must remember these things clearly. I square L, that is integrated injection logic. Next DTL, direct diode transistor logic. HTL, high threshold transistor logic. Next TTL, transistor logic. Okay, these are the different logic families in our logic family here. Okay, please write in your notebook. It can be asked in your exam in 3 marks, 5 marks and 1 mark also. I suggested 3 ways to you. Please clearly and correctly write in your notebooks. Okay, next point. Next, logic families. A miniature circuit on the surface of a semiconductor material is a chip. A small circuit, miniature means small. A small circuit on the surface of a semiconductor material. A semiconductor material is that you already know the semiconductor materials. What are the semiconductor materials? Extrinsic or intrinsic semiconductors are there. That semiconductor material, any of them you can take. A small circuit is placed on that semiconductor material, that it is called a chip. The chip is called an integrated circuit. That chip constitutes the integrated circuit, that is IC. The techniques for manufacturing ICs are bipolar and metal. Here there are two techniques are there for manufacturing of ICs. They are bipolar and metal oxide semiconductor. They are metal oxide semiconductor, MOS. Next, bipolar families are diode transistor logic, transistor logic, emitter coupled logic. Diode transistor logic, transistor logic and emitter coupled logic. Okay, once again repeating the logic families here. A miniature circuit, that is a small circuit on the surface of a semiconductor material, is called a chip. The chip is called a integrated circuit, that is IC. The techniques of manufacturing IC are bipolar and metal oxide semiconductors. Bipolar families are converted into 3 types. They are DTL, TTL and ECL. Diode transistor logic, transistor logic and emitter coupled logic. Okay, please write the definition of chip and integrated circuit here, and the techniques used in manufacturing of ICs are bipolar and metal oxide semiconductors. Okay, most important, 1 mark questions are there. Next one, MOS families. E channel MOSFETs and N channel MOSFET, complementary MOSFETs. First of all, we must know the MOSFET means metal oxide semiconductor field effect transistor. Write in your notebook. MOSFET abbreviation is metal oxide, metal oxide, METALOXIDE, metal oxide field effect transistor, FIELD EFF ECT transistor, TRANSISTOR, metal oxide field effect transistor, MOSFET. Here there are 3 types of MOS families are there. First one P channel MOSFETs, second one N channel MOSFET, third one complementary MOSFETs. Simply we can named it as PMOS, NMOS and CMOS. PMOS, NMOS and CMOS. Next, bipolar technology is faster, used for small scale integration and medium scale integration. Here there are different types of layers of integration also there. First of all, it is SSA means small scale integration, MSA means medium scale integration, VLSA means very large scale integration. These are the different integrations are there. MOS technology is used for LSA, low scale integration, lower scale integration. A digital family is a group of compatible devices with same low logic levels and supply voltages. Sorry. Once again I am repeating. MOS families are three types: PMOS, NMOS and CMOS. Bipolar technologies is faster. It is used for SSA and MSI. SSA means small scale integration, MSA means medium scale integration. Next, MOS technology is used for LSI, low scale integration. Next, a digital family is a group of compatible devices with the same logic levels and supply voltages. Digital families have logic levels same and supply voltage also same. You must remember that one. Logic levels is to be same and supply voltage is to be same for compatibility. There are different types of devices designed by digital families, but for connecting or combining each and every one, we want to know the supply voltage and logic levels of that devices. After that only we can combine each and every device with other. Okay. Here bipolar technology is used for some type of integrations and MOS technology is used for some type of integrations. Bipolar technology is faster and is used for small scale integration and medium scale integration. MOS technology is used for large scale integration. Sorry, low scale no. It is large scale integration, LSI. Okay. It is MOS families. Next, I go for the TTL devices. TTL is a most widely used logic family and it is designated as transistor logic. Here in TTL, the basic element in TTL circuits is bipolar transistor. We already know bipolar transistor is BJT, bipolar junction transistor. Okay. TTL is very fast and inexpensive and easy to use. It is very fast, inexpensive and easy to use. What are the advantages means? We can write this matter. It is fast in one line. Second line, it is inexpensive and it is easy to use. Okay. These are the advantages of TTL devices. Next one, bipolar transistor technology is used for medium scale integration and small scale integration, that is MSA and SSI. And TTL devices are used to build all kind of digital circuits and systems. TTLs are used to build all kinds of digital circuits and systems. One small important thing is there. In some of the TTL circuits, this TTL technology utilizes multiple emitter transistors for the input devices. It uses multiple emitter transistor for input devices. Okay, multiple transistor devices. Once I am repeating, TTL TTL is a widely used family. It uses a basic element known as bipolar transistor. It is very fast, inexpensive and easy to use. Bipolar transistor technology is used for medium scale integration and small scale integration. It is used to build all kinds of digital circuits and systems. It is used to build all kinds of digital circuits and systems. Next, CMOS devices. Now going for CMOS devices here. CMOS specifically stands for complementary metal oxide semiconductor devices. It consists of both N-channel and P-channel MOS transistors arranged in a complementary condition or connection. Here I have given that complementary metal oxide semiconductor devices are chips. They combine P-channel and N-channel MOSFETs. They combine P-channel and N-channel MOSFETs. They are in push-pull arrangement. CMOS devices have very low power. They are used in pocket calculators, watches also. Okay, they are used in pocket calculators and watches also. Once I am repeating, CMOS complementary metal oxide semiconductor devices are chips. They combine P channel and N channel MOSFETs. They are in push-pull arrangement. These devices have very low power. They are used in pocket calculators, watches, etc. They are used in pocket calculators and watches. These circuits have very good noise immunity and very low power dissipation. These devices have very good noise immunity and very low power dissipation than that of the TTL, and hence CMOS devices circuits are greatly used in pocket calculators, digital wristwatches and portable computers. Another applications also there. Portable computers also use these CMOS devices. Okay, CMOS means complementary metal oxide semiconductor devices. Complementary metal oxide semiconductor devices. Okay, this is about CMOS device. Uses also there: pocket calculators, watches and portable computers. Next, these have very good noise immunity and low power dissipation. Okay, these are the important advantages and applications and mode of constructions. Next, ECL devices, emitter coupled logic devices. They are emitter coupled logic devices. The emitter coupled logic is the fastest of all the logic families. It is the fastest of the all the logic families. ECL stands for emitter coupled logic. It is the fastest of all the logic families. Fastest of all the logic families. Then ECL is realized using difference amplifier. ECL can be realized using difference amplifier. Hence they are not driven into saturation. We are using difference amplifier because it is not driven into saturation. We already know amplifier have three types of region: saturation, active and cutoff. Difference has amplifier specialty is it has no saturation region, only cutoff and the active region only. Next, they are used in applications where very high speed is essential. Where very high speed is essential, we use the devices ECL devices. It employs emitter followers at output stage, hence high degree of fan out. It employs emitter followers at output stage, hence high degree of fan out. That means fan out means it is the number of equivalent gate inputs that a logic gate can drive. Fan out means it is the number of equivalent gate inputs that a logic gate can drive. Number of equivalent gate inputs that a logic gate can drive. It employs emitter followers at output stage, hence high degree of fan out. Disadvantage is highest power dissipation per gate. Disadvantage is highest power dissipation per gate. Once again repeating, the emitter coupled logic is the fastest of all the logic families. ECL is realized using difference amplifier. Hence they are not driven into saturation. They are used in applications where very high speed is essential. It employ emitter followers at output stage, hence high degree of fan out. Fan out means the number of equivalent gate inputs that a logic gate can drive. It is nothing but fan out. Disadvantage is the highest power dissipation per gate. I will share some information regarding the ECL circuits. 1 minute. Here we are using a differential amplifier. For this differential amplifier, a bias circuit, and emitter follower outputs are there. These emitter follower output provides OR and NOR functions. This emitter follower output contains OR and NOR functions. By this, there is no saturation in this difference amplifier circuit. Due to this lack of saturation, ECL circuit permit high frequency switching. Due to this lack of saturation, it permit high frequency switching in it. So in this, the VCC pin is connected to ground and 5.2 volts from the power supply is connected to VEE for best operation. Because of low output impedance of the emitter follower and the high input impedance of the differential amplifier input, high fan out operation is possible. By this, high fan out operation is possible. Low output impedance of the emitter follower and the high input impedance of the differential amplifier, high fan out operation is possible for this gate circuit. Okay, it is the ECL devices. Emitter coupled logic is the fastest of all logic families. It is realized using differential amplifier. It consists of a input bias circuit and the output emitter follower circuit. Due to the emitter follower circuit has OR NOR functions, by using this type of functions, it is not having a saturation in it. Due to this lack of saturation, ECL circuit permit high frequency switching. By this, it is having high frequency switching, so that VCC is normally connected to ground and 5.2 volts is normally connected to the VEE for best operation. Because of this low output impedance of the low emitter output circuit and high impedance of the differential amplifier circuit, high fan out operation is possible for this given circuit. Okay, and it employs emitter followers at the output stage for getting the high degree of fan out. The main disadvantage of the emitter coupled logic is the high power dissipation per gate. Okay, this is the ECL devices agenda. Next, specification of digital ICs. Specifications is also termed as characteristics of the digital ICs. First one is propagation delay time. The time taken for the output of a gate to change after the inputs have changed. The time taken for the output of a gate after the input have changed is known as propagation delay time. I will tell you a simple thing also. That is the speed of a digital circuit is specified in terms of a propagation delay time. The speed of a digital circuit is termed as a in terms of propagation delay time. It is the time taken for the output of a gate to change after the input have changed. Power dissipation, second one. It is the amount of power dissipated in a IC. Power dissipation means it is the amount of operation power dissipated in IC. We can inform this with the help of an example that during the operation several amount of heat is dissipated from that logic gate. That amount of this power dissipation in an IC is called as power dissipation. Next one is fan-in. Fan-in is the maximum number of inputs that can be connected. Fan-in is the maximum number of inputs that can be connected. Here I have taken the value of fan-out also. Maximum outputs that can be connected. Fan-out means it is the maximum number of outputs that can be connected. Next one is noise margin. The circuit ability to tolerate noise signals is noise immunity, and a measure of this is noise margin. A circuit ability to tolerate noise signals is noise immunity, and measure of this is noise margin. Okay. Once I am repeating, propagation delay time. The speed of a digital circuit is termed as the propagation delay time. So the speed of operation of propagation delay time is the time which takes the output of a circuit or gate to change all the circuits that so circuit inputs have changed. Next, power dissipation. Power dissipation is the amount of power dissipated in an IC. That means during the operation the power taken by logic gate is called power dissipation. The power dissipation of a logic gate equals to the DC supply voltage VCC times the average supply current ICC. VCC by ICC is called the power dissipation. PDC equal to power dissipation PD equal to ratio of VCC to the ICC. Next, fan-in. It is the maximum number of inputs that can be connected. Fan-in. It is the maximum number of inputs that can be connected. Fan-out. It is the maximum number of outputs that can be connected. It is the maximum number of outputs that can be connected. Noise margin. The circuit ability to tolerate noise signal is called noise margin, and measure of this is noise margin. That is, noise margin is the noise is an unwanted voltage induced by stray electric fields and magnetic fields when connecting wires between the logic circuits. In logic circuit, this may produce undesired operation. Hence, the ability of circuit which tolerate these noise signals is known as noise impurity, a quantitative measure of which it is called noise margin. The ability of this circuit to operate in a noise environment is important in many applications. Can be tolerated by the gate. The noise margin for TTL and CMOS ICs is 0.4 volts and 3 volts respectively. Hence, CMOS ICs can perform better in a high noise environment. Next, fan out. This is the number of equivalent gate inputs that a logic gate can drive. So, the fan out of a gate is the maximum number of inputs of the same logic family that the gate can drive while maintaining its output levels within specified limits. Okay, these are the specifications. Some more specifications also there. I will let you know. They are basic gate. The logic gate which is normally employed in logic's family for its basic operation is known as basic gate of that family, and from which the other logic functions can be developed. Another one is logic levels. The voltage or currents that are used to represent a logic state. The voltage or current that can be used to represent a logic low state, that is 0 level, and high state, that is 1 level. For this, let us consider voltage and current parameters. Here logic levels are the voltage or current that is to be represented. A low level as well as a high level. Low level means 0 level, high level means 1 level. Okay, basic gate is the gate which is used by the logic family. For its basic operation is known as basic gate of that family, from which the other logic functions can be developed. These are the specifications as well as the characteristics of logic families. Specifications as well as the characteristics of logic families here. Now, comparison of logic families. Comparison of logic families. We already know there are three types of logic families: TTL, ECL and CMOS. First of all, I will inform the row items and column items. Logic family. First of all, we must know the noise margin, that is V, fan out, fan in, propagation delay in nanoseconds, power dissipation in milliwatts. Power dissipation in milliwatts. For TTL, it is 0.5 volts. Noise margin is 0.5 volts and fan in is greater than 10. Fan in is greater than 10. Next, fan out is greater than 10. Next, fan in is 12 to 14. Power propagation delay is 10. Power dissipation is 10. Once I am repeating, for TTL, noise margin is 10, as well as noise immunity is good, very good. Fan out is greater than 10. Fan in is 12 to 14. Propagation delay is 10 nanoseconds. Power dissipation is milliwatt is 10 milliwatts. Now for ECL. ECL noise margin is 0.16. And noise immunity is poor. And fan out is greater than 10. Fan in is greater than 10. Propagation delay in nanoseconds is less than 3. Propagation delay in nanoseconds is less than 3. And power dissipation in millivolt is 175. Whole circuit, it is 175 is whole circuit. Per gate is 40 to 55 milliwatts. Now for CMOS, noise margin is 1.5 and noise immunity is very good. For ECL only, noise immunity is poor. Rest up to TTL and CMOS, it is very good. Next, fan out is greater than 10. In most cases, it is greater than 50 also. Next, fan in is greater than 10. Propagation delay is 15 nanoseconds. And power dissipation in milliwatts is 0.001. Power dissipation in milliwatts is 0.001. In static at 1 megahertz. In static as well as in 1 megahertz, it is the comparison of logic families. One thing is also I wish to share, it is the basic gates for that. For TTL it is NAND. For TTL it is NAND gate we can use. For ECL we can use OR NOR operations, OR NOR gates. For CMOS, NOR or NAND. For CMOS, NOR and NOR or NAND. Okay, once I am repeating, row values are logic family, noise margin and noise immunity, fan out, fan in, propagation delay in nanoseconds, power dissipation in milliwatts. First of all, for TTL, noise margin is 0.5 and noise immunity is very good. Fan out is greater than 10. Fan in is 12 to 14. Propagation delay is 10 nanoseconds. And power dissipation in milliwatts is 10. Okay. And basic gate is NAND gate. TTL, it is used is, the gate used is NAND gate. For ECL, noise margin is 0.16. Noise immunity is poor. For fan out is greater than 10. Fan in is greater than 10. Propagation delay is very less than 3. And power dissipation in milliwatts is 175 for all the circuit, and for our gate is 40 to 55 milliwatts. Next, the basic gate for ECL is OR NOR basic gates. Next, for CMOS logic family, noise margin is 1.5. Noise immunity is very good. Fan out is greater than 10. It might reach to greater than 50 also. And fan in is greater than 10. Propagation delay is 15. And power dissipation in milliwatts is 0.001 in static at 1 MHz. Okay, it is the comparison of logic families. Next, CMOS logic ICs values I have given here. That is what 2 input gates, 4000 series CMOS logic ICs I have given here. What 2 input gates, 4001 what 2 input NOR, 4011 what 2 input NAND, 4030 what 2 input XOR known obsolete, 4070 what 2 input XOR, 4071 what 2 input OR. Once again repeating, what 2 input gates, 4001 what 2 input NOR, 4011 what 2 input NAND, 4030 what 2 input XOR, 4070 what 2 input XOR, 4071 what 2 input OR. Please write in your notebook. It is the 4000 series CMOS logic ICs. 4000 series CMOS logic ICs. So, some more is there. 4077 what 2 input XOR, 4081 what 2 input AND, 4093 what 2 input NAND with schematic trigger circuits. Schematic trigger we will learn in afterwards. I think schematic trigger is in EDC also, electronic device circuits. You may learn from that also. Okay. Once I am repeating, quad 2 input gates, 4001 quad 2 input NOR, 4011 quad 2 input NAND, 4030 quad 2 input XOR, quad 4070 quad 2 input XOR, 4071 quad 2 input OR, 4077 quad 2 input XNOR, 4081 quad 2 input AND, 4093 quad 2 input NAND with schematic trigger inputs. These are the 4000 series CMOS logic ICs. Now summary. We have discussed about the TTL, CMOS and ECL logic families here, and specifications of these logic families or characteristics of these logic families we have learned here, and comparison of the logic families based upon the noise margin, noise immunity, basic gate, fan in, fan out, propagation delay, power dissipation, and digital IC numbers also. Here I wish to share some regarding some numbers of the IC, digital IC numbers here. 1 minute. Please make a note of it. It is also digital ICs. That is, TTL ICs are widely used and the most popular family of small scale integration and medium scale integration IC chips are listed below. They are 7432. Please note that in your notebook. 7432 is the OR gate. OR gate is 7432. 7408 is AND gate. 7408 is AND gate. Once I am repeating, 7408 is AND gate. 7404 is not gate. 7404 is not gate. 7408 is for 7402 is not gate. NOR gate. Sorry, NOR gate. 7400 is NAND gate. 7486 is XOR gate. 7486 is XOR gate. Once again repeating. 7432 OR gate. 7408 AND gate. 7404 NOT gate. 7402 NOR gate. 7400 NAND gate. 7400 NAND gate. 7486 XOR gate. Okay. In these TTL ICs have both 7400 series and 540 series. Here 7400 series works over a temperature of 0 to 70 degrees Celsius and supply range is 4.75 to 5.25 volts. And 5400 series are developed for military applications, works over a range of minus 55 to 125 degrees Celsius and supply voltage range is 4.5 to 5.5 volts. 4.5 to 5.55 volts. Now we are going for quiz. Any digital family is a group of compatible devices with the same logic levels, and answer is, I know that supply voltage is the answer. Any digital family is a group of compatible devices with the same logic levels and supply voltages. First one, please note in your notebook. Any digital family is a group of compatible devices with the same logic levels and supply voltages. Next two, which logic family is the fastest logic family? Here ECL is the fastest logic family here, but for ECL noise margin and noise immunity is very poor. Third one, a logic family is fastest because it operates in cutoff and active region, because it doesn't have saturation region. Due to the usage of logic family is fastest because it operates in cutoff and saturation region. Okay. Next, I share the frequently asked questions here. Please note down these questions and write it in your assignment book. Write about the specifications of logic families. Please, specifications is also known as characteristics. If any question regarding the characteristics came in, you must write the answer of the specifications of logic families here. I already know that. First one, basic gate. Second one, logic family. Next, logic level. Next, noise margin, noise immunity, power dissipation, propagation delay time, fan in and fan out. These are the specifications of logic families. Next, comparison of logic families based upon the specifications of logic families. TTL, ECL and CMOS. Next, list any 4 digital numbers. I have told to you 7402, 7400, 7486, 7408. Likewise, they are the digital IC numbers. With their gate also we want to represent in it. Okay. Thank you. Thank you for hearing my class. This is the lecture regarding the digital logic families. First question you must remember is, here I have not remember that question. That fourth question is list the digital logic families. Please write that question also in your assignment book. Thank you. Thank you for hearing my class.